Hello my dear friends, welcome to our today's class. It's our fourth and last lesson on the topic fluid flow. So as usual, let me commence by giving you the quote of the day, which states that be careful not to confuse lack of experience with inability. So we shall discuss that quote at the end of our class today. So today we are looking at the Bernoulli's equation, of course, which was discovered by a Swiss mathematician by the name Daniel Bernoulli. He was the same guy also under the Bernoulli's effect. So under this, we consider a liquid of mass m flowing through a pipe with velocity v. Then we let the pressure at a given point be P. Now we know that kinetic energy per unit volume means the kinetic energy divided by the volume. Later on we shall see from a given topic in Form 3 called work energy, power and machines, that kinetic energy of a given body is always given by a half times the mass of the body times the square of the velocity at which that particular body is moving at. Then also remember that kinetic energy is usually the energy possessed by a body in motion. Then divided by volume. Volume in physics we denote by capital V, but small v in physics usually denotes the velocity. In some cases it might denote the final velocity. So if this shall give me a half m v squared divided by v. But we know from measurement 1 that density is equals to mass divided by volume. So if I substitute mass over volume for rho, remember rho is usually the density, that a Greek word, which a Greek letter which denotes the density in a liquid, that is in a, or in fluids. It can be in a gas or in a liquid. So because mass over volume is density, that means my kinetic energy will be given by a half rho v squared. Similarly, potential energy per unit volume will be given by potential energy divided by volume. And later on we shall also see in the same topic that potential energy is usually the energy possessed by a body in rest, of course, at some height from the ground or the level ground. So potential energy, we shall see that is usually given by mass of the body times gravitational pull times the height above the ground. So again, we know that mass over volume gives us the density. Therefore, if I substitute rho for mass over volume, I shall have potential energy being equal to rho gv. That is density of the fluid times the gravity times the height above the ground. Now, the Bernoulli's principle states that for an incompressible non-viscous fluid in a streamlined flow, the sum of pressure, kinetic energy per unit volume, and the potential energy per unit volume is a constant. So mathematically, when we talk of sum, we mean addition. So in equation form, we can say that the Bernoulli's principle states that for an incompressible non-viscous fluid in a streamlined flow, P, that is, just consider this particular statement here, the sum of pressure, that is sum pressure, which is denoted by capital P, plus stands for sum of pressure, and the kinetic energy per unit volume. Remember, kinetic energy per unit volume, we found its equation as a half rho v squared. So plus kinetic energy per unit volume, and the potential energy per unit volume. Remember, potential energy from above here we derived its equation as rho gh. So plus rho gh is equals to is a constant. So what this statement simply means is that if you take the sum of the P1, that is pressure at point 1, plus a half times density of that particular fluid at point 1 times the velocity of the fluid at point 1 plus density of the fluid at point 1 plus the gravity of the fluid at point 1 plus the height of the fluid at point 1 should be equal to the pressure P2 plus a half rho 2 v squared 2 plus rho 2 g2 h2. That is that the sum of the pressure, kinetic energy per unit volume, and the potential energy per unit volume will be the same throughout the flow of that particular fluid. That is what this particular statement means. So maybe you can as well state the Bernoulli's principle in form of an equation, provided that you give the conditions under which such an equation holds, then you define what each quantity denotes. For example, if you want to state the Bernoulli's principle in terms of the equation, you can say that for an incompressible and viscous fluid in a streamline flow, P plus a half rho V squared plus rho GH is equals to a constant, where P is the pressure at a given point in that particular fluid, rho is the density of the fluid, V is the velocity of the fluid, then of course G is the gravitational pull, and H is the distance moved by that particular fluid, or the height covered by that particular fluid. So the two equations are acceptable. Then again, don't confuse the Bernoulli's effect with the Bernoulli's principle. We looked at the Bernoulli's effect from our previous class, which was giving us the relationship between velocity and pressure. But the Bernoulli's principle talks of the summation of the pressure times, that is the summation of the pressure, kinetic energy per unit volume, and the potential energy per unit volume being a constant, that is throughout a liquid, meeting the conditions of incompressibility, non-viscosity, and streamline. Next, we look at the applications of the Bernoulli's principle. First of all, we start with aerofoils. So aerofoils, this is just a structure. It is a structure constructed in such a way that the fluid flowing above it moves in a higher speed than the fluid flowing underneath or below it. So examples of aerofoils include the aircraft wings, the helicopter, rotor blades, etc. So because the fluid flowing above the aerofoil has to travel along a distance, that is, just look at my aerofoil. This is my airflow, which is the fluid in this particular case. So if you compare the streamlines of the air flowing above these particular aerofoils and the streamlines of air flowing below the aerofoils, you will see the difference. That is, the streamlines, because the aerofoil on the upper side, it is somehow it is peaking at the upper side, while on the lower side it's just straight. It means the streamlines on the upper side will somehow bend, covering a very long distance within the same period of time. That is, the distance covered by these particular streamlines to move from this point up to this point, of course, it will be longer for the upper streamlines as opposed to the lower streamlines. That is, as it can be seen clearly here, because for the lower streamlines, they are just moving directly or in a straight line from point A towards point B. But for the streamlines on the upper side, they are covering a longer distance because they are moving from this point, they are moving upwards. That is, we can consider like for an hypotenuse, then they start moving downwards at a very high speed because, of course, they are also raised at some height. It means something like their gravitational potential is high. Therefore, we expect this particular fluid, that is the air at this point, to move at a higher velocity as compared to the velocity on the lower side. Now, we know that speed is equals to distance over time, or velocity is displacement over time. So if I hold time constant, it means the speed or the velocity will be directly proportional to the distance covered. That is holding time constant. So because the time taken for the streams of air to move from this point to this point, assuming it is something like 10 seconds, obviously the streams on the upper side are covering a longer distance. Therefore, if we want them to arrive at this point at exactly the same time, then the streams on the upper side have to move at a higher speed so that they reach at this point at the same time with the streams on the lower side, or the streams that are underneath. So because the upper streams are covering a longer distance, it means they are moving at a higher speed or at a higher velocity. Remember, speed and velocity are the only difference is that velocity is a vector quantity, that is, has an aspect of direction, whereas speed is a scalar quantity, which means we only take care of the magnitude, but we ignore the aspect of direction when it comes to speed. So because the streams on the upper side are covering a longer distance, it means they are moving at a higher velocity. Courtesy of Bernoulli's effect, when a fluid is moving at a higher velocity, that is, if it's meeting the conditions, then such a fluid must be flowing at a low pressure. That is, the Bernoulli's effect talked of the inverse proportionality of the velocity of the fluid and the pressure at that particular point. So that means if the fluid on the upper side is moving at a higher velocity, the pressure P2 on the upper side is low. Conversely, the fluid on the lower side, because it is taking a very short distance, it is covering a short distance from point A towards point B within the same period of time. It means the fluid or the streams of air at the lower point, they are moving at a very, very low velocity or at a very low speed compared to those on the upper side. Reason being, they are covering a shorter distance within the same time with the streams of air on the upper side. So because the streams on the lower side are moving at a low velocity, courtesy of Bernoulli's effect, if a fluid moves at a low velocity, then such a fluid is moving under very, very high pressure. So because the pressure on the lower side, P1, is greater than the pressure on the upper side, P2, it means now we have created what we call a pressure difference. And whenever pressure difference is created, it will form what we call a dynamic lift force. It will produce a dynamic lift force that will lift this particular aerofoil upward. So that's why the aerofoil is able to be uplifted upward. So of course, the force due to the dynamic lift will be given by the pressure times area, the pressure difference times area. That is P1 minus P2 times the area, because P1 is the greater pressure here. The same case, for example, the propeller of something like a helicopter operates on the same principle. So the propellers are made in such a way that they are streamlined bodies, such that on the upper part, and there are aerofoils also, such that on the upper part, the streamlines will be covering a longer distance. Therefore, if they are covering a longer distance, automatically within the same period of time with the streamlines underneath or on the lower side, it means the velocity of the streamlines on the upper side is very, very high. Then automatically the pressure will be low, courtesy of Bernoulli's effect. And conversely, the velocity of the streamlines on the lower side are very low, because they are covering a shorter distance within a long period of time. So if the velocity is low, it means the pressure exerted on the lower side by the streams of air will be very, very high. So it means we now have a pressure difference such that the low pressure is higher than the upper pressure. So the body, in this case the helicopter, will be lifted upwards. However, if you want the helicopter to be lifted to even greater heights, you simply, that's why when you see when helicopters are just about to take off, the propellers usually start to rotate. Remember, when the propellers are rotating, the air above it, they are increasing the speed of they are displacing the air above it, and therefore it means the speed or the velocity of the air above these particular propellers will be moving at a very, very high speed. And remember, velocity and pressure are inversely proportional. So if the velocity of the air, of the streams of air above the propeller when it is rotating is very, very high, it means the pressure above that particular propeller is very, very low. Now, that means that the atmospheric pressure on the lower side, acting on the plane, on the helicopter from the lower side, is now greater than the reduced pressure on the upper side. So because of the greater atmospheric pressure, than the pressure of the streamlines of air above that particular propeller, so the indifference in pressure, that is what provides a greater dynamic lift force, which enables the aeroplane to move upwards. Next, we look at the Bunsen burner. So the Bunsen burner is usually connected to a gas cylinder. They are usually connected to gas cylinders. So now, it's the velocity of the gas from the gas cylinder is usually reduced. No, it is usually increased at the nozzle. So remember, a nozzle has a smaller cross-sectional area, which means it's a constriction. And we know that a smaller cross-sectional area from the equation of continuity, that a smaller cross-sectional area will always mean that the fluid is moving at a very high velocity. And remember, if a fluid is moving at a high velocity, then the pressure it's exerting is very, very low, courtesy of the Bernoulli's effect. So it means the gas pressure in the barrel that is above the constriction is low. The reason being, when the gas gets from the gas cylinder, it gets into the constriction that reduces the cross-sectional area, hence increasing its speed from the equation of continuity. And when the velocity or the speed is reduced, automatically the pressure of the fluid becomes very, very low. So the pressure of the gas becomes very low, therefore the gas flows above the nozzle at very, very low pressure. And when the pressure of the gas in the barrel is low, it means now the atmospheric pressure acting from the outer on the air, which is outside the barrel, is now very, very great. So the atmospheric pressure acting from the outer side being greater than the pressure of the gas inside the barrel forces the air to get through the air hole into the barrel. So the air is forced into the barrel through the air hole because the atmospheric pressure is greater than the reduced gas pressure inside the barrel. So the indifference in pressure, that is what forces the air to be pushed into the barrel. So as the air is pushed into the barrel, it meets with the gas from the gas cylinder, they mix up and they move upwards. Then of course, so the air and the gas then mix as they rise upward, and when ignited, a flame is produced. To ignite simply means to heat them or to increase their temperature beyond their ignition point, whereby it will cause a flame to be produced. Next, we look at what we call the spray gun. The spray gun, it usually has we have what we are calling a piston, then we also have a leather washer. So what happens is that when the piston is moved forward, air is made to flow through the barrel, some of it going down tube A and the remainder blowing past the mouth of tube B. So when the piston is moved forward, that is towards the right hand direction, the leather washer pushes the air, that is, it pushes the air towards the same direction. So when air is pushed, when it gets to tube A, some of it goes down to tube A. So some of the air is pushed down to tube A. And remember, when the air is pushed down to tube A, there was already some air inside this particular container here, that is this large container here. But now when you are increasing another air which is under high pressure, it means you are increasing the pressure that is being exerted on this particular liquid. At the same time, the air that did not enter into tube A continues with the flow. So some of the air continues past tube B. So remember, at tube B, if you consider my barrel here very well, at this point it has a larger cross-sectional area, then the cross-sectional area diminishes or reduces as towards the nozzle. So at this particular point B, note that point B is in the region where the cross-sectional area is somehow smaller. And remember, the smaller the cross-sectional area from the equation of the continuity, the higher the velocity of the fluid. So it means the air that passed point A to point B is moving at a very high speed because of the very, very low cross-sectional area. Therefore, it is passing at a very high velocity. From the Bernoulli's effect, if the velocity of the air above B is very high, it means the pressure exerted by that particular air is very, very low. Now we have a pressure difference. We have a high pressure being exerted on this particular liquid due to the air that entered through A, but at the same time, the air that was passing through B, that is at B is under a smaller cross-sectional area as compared to this region here. So it means the air at that particular point is moving at a very, very high speed due to the smaller cross-sectional area. Therefore, if it's a very high speed or velocity, it means the pressure exerted is very, very minimal. So the pressure at above B is very low, while the pressure being exerted on the liquid in the tube is very, very high. So that indifference in pressure forces the liquid to be compelled to move up tube B and blown to the nozzle by the air from the barrel. So the indifference in pressure will force this particular liquid to flow up tube B. Now when the liquid gets here, remember some of the air that bypassed point A is still flowing towards the right hand side. So that air, again, it pushes the liquid. Once it gets up point B, it is pushed by the air into the nozzle. Then remember, the nozzle is usually very, very tiny. That is, it has the smallest cross-sectional area. And when the cross-sectional area is very small, automatically from the equation of continuity, the velocity of the fluid will be very, very high. So the velocity of the liquid is increased as it passes through the nozzle because of the reduced cross-sectional area and a high velocity. So the liquid thus emerges as fine sprays. So the liquid emerges as fine sprays because the nozzle ensures that the velocity at which it gets out with is very, very high. Remember, if you used a larger cross-sectional area, the liquid will not emerge into fine sprays. Rather, it will just be poured into under some pressure, but it won't be under fine sprays. Next, we look at the carburetor. So the carburetor, this is just a cylinder or an instrument that is used in ensuring that you get the right mix of the air and the petrol inside the car engines. So it usually has what we call a venturi. So what happens is that due to the action of the engine pistons, air is drawn into the venturi. Air is drawn into the venturi. So the fast moving air causes the low pressure above the petrol pipe. So remember, if air is moving inside the venturi under very, very high pressure, maybe you may be wondering what is a venturi. So a venturi is coming from the word venturimeter. That is a venturi meter. This is just a device used in measuring the volume flask of a fluid. So of course, it got the name venturi because it was invented by an American engineer called Clemens Herschel, and it was named by an Italian physicist called Giovanni Venturi. So because of the second name Venturi, it was given the name a venturi. So the fast moving air causes low pressure above the petrol, that is the petrol pipe. So if this air is being sucked here under very, very high velocity, remember high velocity from the Bernoulli's effect means the pressure will be very, very low. So the pressure inside the venturi is very, very low. Now it means that the atmospheric pressure acting on the floater chamber, that is through the air vent, is now higher than the pressure in the venturi. So because of the greater atmospheric pressure acting on the float chamber, the greater atmospheric pressure forces this particular petrol to flow through this particular tube and into the low pressure zone. So the fast moving air causes low pressure above the petrol pipe. So the petrol is drawn into the venturi due to low pressure in the venturi and atmospheric pressure in the floating chamber being higher. Therefore, the mixture of air and the petrol is thus drawn into the cylinders for combustion. It is now drawn into the cylinders for combustion. So this is now the mixture of air and petrol. So remember, a venturi, that is the carburetor, usually ensures that you get the right ratio of mixing the air and petrol. Usually, they are usually mixed in the ratio of 15 to 1. That is the air being in the ratio of 15 while the petrol being in the air of 1. So to ensure that your car or your vehicle functions really well. Then lastly, we look at the hazards of Bernoulli's effect. Hazard simply means a negative effect. A negative effect. So first of all, we look at blowing off of the rooftops. So actually the Bernoulli's effect can lead to blowing off of the rooftops, such that the air flowing over a rooftop has a higher velocity compared to the one flowing underneath. So remember here that some of the streamlines of air will be moving straight above maybe your rooftop in a straight manner. So of course the streamlines of air moving from this point, that is, we can call this from point A, moving from point A towards point B, it's just taking a straight path as opposed to this one which is moving upward, then again straight, then it comes downward. So obviously, if we take time to be constant, and we have seen that whenever time is constant, then the velocity will be directly, that is, the velocity or the speed will be directly proportional to the distance covered. So at a constant time, it means that the streams of air that chooses the path of from this point downwards straight up to this point will be covering a shorter distance. And we are saying that distance is directly proportional to velocity if we hold time constant. So because the streamlines of air passing above our rooftop is because the velocity of air of streamlines passing above our rooftop is very, very high because it is covering a longer distance. Remember, a higher velocity from the Bernoulli's effect means that the pressure at the upper part will be very, very low. Therefore, P1 is a very, very low pressure. Conversely, the pressure at the velocity of the streamlines of air at the lower part of this particular rooftop, the velocity is very, very low because these particular streamlines will be covering a shorter distance within the same period of time taken by the upper streamlines of air. So because they are covering a shorter distance, it means they are moving at a very, very low velocity. And from the Bernoulli's effect, if the velocity is low, automatically the pressure will be very, very high. Therefore, P2 is far much greater than P1. So because of the pressure difference, that is P1 being greater than P2, that is what provides a lifting force. So that can cause your rooftop to be lifted, leading to blowing off of your rooftop. Hence, that is a negative effect. Next, we look at the road accidents. So in the road accidents, usually a small car traveling at a very high speed is likely to be dragged into the long truck traveling in the opposite direction, also at a very, very high speed. So this is because the air in between them moves with a very high speed, reducing the pressure between them. Therefore, the atmospheric pressure acting from the sides of the two vehicles will push them closer together, increasing the chances of an accident. So if this is your car moving towards the right-hand direction and this is a heavy truck moving towards your left-hand direction, remember, if they are moving at very, very high speeds, it means the air in between them. And if they are moving at high speeds and closer to one another, it means the air in between them is under very, very high velocity, So because the air in between them is under very high velocity, it means a higher velocity means that the pressure in between the two vehicles will be very, very low, courtesy of Bernoulli's effect. So if the pressure is low, it means now the atmospheric pressure acting from both vehicles from the outer side is now greater than the pressure in between the vehicles. So the excess atmospheric pressure will cause these vehicles to be pulled closer, far much closer to each other, because the car will be moved from a high pressure zone towards a low pressure zone, which is the region where your heavy truck is located. So such vehicles can crash, leading to an accident which can be catastrophic. Then the same principle is applied in whereby you find most trees usually that are close to the road, they bend towards the road, especially if you have fast moving vehicles on that particular road. So the reason is because a fast moving vehicle causes the air close it to move at a very, very high velocity. So if the air is moving at a high velocity, then the pressure it exerts will be very, very low, courtesy of Bernoulli's effect. So if the pressure is low, it means the atmospheric pressure acting from the outer parts of the tree is now higher than the pressure near the road. So because of the excess atmospheric pressure, that is what can cause the trees to bend towards the road, and sometimes they can even fall on the road, causing some accidents. It's the same principle whereby you can be seated, opening your door widely, and when some wind blows, you see your door closing. So the reason is because when the wind blows, the air passes in between the open gap of your door. So if that is the speed of the air passing at the open gap of your door is increased. So the blowing wind increases the speed of the air passing at the opening end of your door. Therefore, if the velocity of the air in between the door is very high, automatically the pressure at that point will be very low, courtesy of Bernoulli's effect. So if the pressure is low in between the opening gap of the door, it means now the atmospheric pressure acting from outside on the door, on the outer parts of the door, is now greater than the pressure in between the door. So the atmospheric pressure being greater, it pushes the door from a high pressure zone to a low pressure zone. Hence your door closes. The same case acts for windows. So actually physics is very, very practical in real life situation. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that so the quote of the day actually stated that be careful not to confuse lack of experience with inability. So many of us are afraid of experimenting new ideas in life because we don't believe that we have the ability to execute them successfully. But guess what? That is not just very true, because I believe that each and every human being was born with the ability to do anything, provided that you are willing to learn and you are willing to put in the effort required to perform that particular task. So do not confuse your inability, your inexperience with inability. So if you don't have an experience to do something, that does not mean that you are not able. Actually, if you do that thing over a given period of time, you also become an expert, because remember that all experts were once beginners. All experts were once beginners. So what you need to do is that you have to be willing to do the work, or you have to be willing to go through the experience in order to perfect your skills. And lastly, remember that you cannot expect your physical health to improve when you just read about improvement of the physical health. That means that if you want your physical health to improve, you have to do the physical exercises, because if you just read and you do nothing about it, actually that won't improve your physical health. So you are just being pushed into taking action. So in the same case, if you want to learn anything, if you want to learn any skill in life, you have to be willing to go through the experience of learning that thing. So no matter how much knowledge you have, if you don't take action, that knowledge won't help you much. This is Kind Tuition Academy. I'm very excited to having completed the Form 2 syllabus. It will not be possible without your comments, without your views, without your encouragement. I just want to say thank you very much. So expect us to start book 3 in our next lesson. Thank you very much. Until next time.